Box 8.3 is a typical problem in soils, and what it's going to describe is, and so we'll just read through this second paragraph here. Assume you know that a cultivated mollisol in Iowa contains 20% clay and 4% organic matter, and its pH is 7. The dominant clays in mollisols are likely 2-to-1 types such as vermiculite and smectite. We estimate the average CEC of these clays of these types to be about 100 centimoles of charge per kilogram of clay. We've seen that before in the tables. At pH 7, the CEC of organic matter is about 200 centimoles of charge. Since 1 kilogram of the soil has 0.2 kilograms of clay, so 20% of a kilogram is clay, of this material is clay, and 0.04 kilograms, that's 4% of 1 kilogram, is organic matter. We can use both those things. We can say, okay, well, this 0.2 that we're seeing here, I know that 1 kilogram of this kind of clay has 100 centimoles of charge in it, right? So I only have 0.2 kilograms. I don't have a whole kilogram, I just have 20% of a kilogram. Times that 100 centimoles gives you 20 centimoles of charge from the clay in the mollisol, from the vermiculite, from the smectite in the mollisol. So that's one part of it. The other part of it is the organic matter. We know we only have 0.04 kilograms out of 1 kilogram, right? We only have 4% of a kilogram. So 0.04 kilograms times that 200 centimoles of charge gives us 8 centimoles of charge from the organic matter. So this is OM, this is from clay. We add those together and we get 28 centimoles of charge per kilogram if we only know the type of clay and the percent organic matter. Those are the only two things we knew. We have other information about what kind of clays might be in that soil. We have information about how much CEC is in those clays, how much CEC is in the average organic matter at pH 7. So this allows us to, in a very, very gross way, a fast way, determine what the approximate CEC of that kind of soil is. Now, I mentioned that we have another way of determining CEC from soils, and that is, if we have a soil, for instance, with negative charges on it, and we have all sorts of things on the exchange sites. What we can do is we can basically flood this system with a bunch of, you name it, let's just say potassium. Okay, we'll just write a bunch of potassiums that'll go into this solution, and they'll take each one of these and basically bump them off. We can collect a solution of that, and we can determine what the CEC is based on how many of these cations actually came out of the solution. Maybe we might see that it's 30 centimoles of charge per kilogram. Okay, that's another way we can determine the CEC of a soil is through that. But typically, what we find in soil science, and in you might see this on a quiz or a test, is estimating the CEC because we know about different kinds of clays. We know that vermiculite, smectite / montmorillonite is 100 centimoles of charge per kilogram. We know that organic matter typically is 200 centimoles of charge, and so we can estimate what we've got in a particular kilogram of soil if we know these percentages right here and the type of clay that we've got.